Okay, good morning children once again. We have the students of classes 9th with the physics chapter currently going on. So if you remember, this is the second lecture that we are going to start with, and the name of the chapter, obviously, if you remember, on the previous day we had started with measurement and experimentation. Okay, I had given you a brief idea of what measurement is and its definition, along with the choice of the units, what is a unit, what is a physical quantity, and all those things. So let us draw down from what we had done in the previous lecture. So I have listed down a few things from the previous lecture also. If you see measurement with an arrow, it shows what is basically measurement. It was the comparison. Okay, comparison between what? So there are two things. One will be an unknown quantity and the other one will be a known standard quantity. Now it is very obvious for a person to know that the quantities that are being compared, they have to be of the same nature. Okay, this is something that we had forgotten to mention in the previous lecture, although I assume that it would have been obvious for you to understand that the quantities which are being compared, they have to be of same nature. For example, you cannot measure the length of a pencil using a kilogram weight. Okay, why? Because 1 kilogram represents mass. Okay, whereas the length of the pencil is to be measured in centimeters or meters. Alright, so these are two different quantities, or quantities of different nature. Okay, so we can't compare them. So obviously, if you want to determine the length of a pencil, it has to be in terms of meters or centimeters. Okay, so these comparisons have to be between the quantities of the same nature, and obviously those quantities will be physical quantities because we have to quantify them, we have to put a number to them. Okay, so this is a brief revision of what we had done. Now coming to the next part, where if you remember in the previous lecture, once again the point where we had stopped was when we were discussing the kinds of units. So one was the fundamental or the basic unit and the other one was the derived unit, and we had also discussed the basic difference between them. The basic or the fundamental unit, as the name suggests, it is a standalone unit which is not dependent on any other unit. In fact, there are other units called derived units which are dependent on the basic unit. So basic units, they were chosen right in the beginning. So if you have a look, I have listed over here some of the basic or the fundamental units that we have. Now to begin with, these three are the most basic ones, or the ones that came into existence originally. Okay, so length is obviously a physical quantity, mass another physical quantity, time another very basic physical quantity. Okay, so the things that I have mentioned on the left hand side over here, these represent the physical quantities. Okay, whereas after the arrow, what I have mentioned, these are the units which pertain or which are related to these physical quantities. Okay, so these are the names of the physical quantities and these are the units that pertain to them. Okay, and obviously they all come under the heading of basic or fundamental entities. Okay, so if we talk about length, mass, time, amount of substance, current, temperature, all these are basic physical quantities or fundamental physical quantities. Okay, similarly, if we talk in terms of basic units or fundamental units, length, which is represented by meter, small m, this is a fundamental unit. Okay, similarly, kg is a fundamental unit, second is a fundamental unit, mole, mol, which is a unit, basic unit to represent amount of any substance, that is also a fundamental unit. So similarly, for current you have capital A standing for amperes, then you have for temperature you have Kelvin, and similarly luminous intensity you have candela. Okay, so these ones, the ones mentioned on the right hand side of the arrow, these are the fundamental units. If you count them, these are basically 7 in number. Okay, so these are the fundamental units which are not dependent on any other unit, they are standalone. Okay, and what do these units represent? Since these are fundamental units, they will represent some fundamental physical quantities, which are length, mass, time, amount of substance, current, temperature, and luminous intensity. So if you basically want to go into the history of these things, these three were the ones in mechanics. These three were the ones that were discussed or originated or worked upon in the beginning, and then later on they decided that they would include these other fundamental quantities as well. So these are the basic or the fundamental units, and similarly we have the derived units. If you remember, they will be derived, as the word suggests, derived or taken, or they are dependent on the fundamental unit. So in derived there is no limitation, there are numerous of them. For example, you can list meter per second, then you can have meter per second squared, then you can have kilograms per meter, and so on and so forth. So that this list basically is endless. Okay, and as you can see, as the word also suggests, meter per second is a derived unit. Why? Because it has been taken from meter as well as from second, both of which are fundamental units. Okay, so as far as the basic and the derived units are concerned, this was a detailed idea. Now the next thing that we will go to is systems of units. Okay, systems that have been incorporated. Okay students, so here we are. Let us have a look at the system of units. Okay, so we will, although I have to avoid the wastage of time, I have listed down a number of things on the board over here, but we will just have a look at the system of units first. Okay, so what are these systems of units? Basically, what was the reason why we had to design or we had to establish these different systems of units? Because if you understand, if you try to basically reflect on the kind of measurement and the vast variety of measurements that we undertake here in India, where along with India we have different other countries, localities, different places on earth where we have to have measurements happening. Okay, so in the beginning, originally, if you see, there were three systems. There was one known as CGS system, capital C, capital G, and capital S, CGS system. Then we had FPS system. Then we also had MKS system. So if you understand, if you try to understand, C over here represented centimeter, and obviously centimeter is a unit of length. Okay, similarly G is for grams. Okay, and gram is the unit of mass. Similarly second for time. Okay, so length, mass, and time. Length, mass, and time. If you remember in the previous list that we had discussed, these were the three basic or the fundamental quantities or the standalone quantities or the units that were previously discussed. Okay, so CDS system, we have centimeters, we have gram, we have second, and this was basically the other name for this kind of system was the French system, because the French people or the France as a country was basically using this on a large scale. Okay, similarly we had other European nations, or basically the British system is the next one. So we have FPS. F represents foot or the feet, and then you have P representing pound, okay, which is represented in terms of the symbol as small l, small b, and then S obviously is for seconds. Okay, so this again, once again, this fit is for length, pound is for mass, and S, which is second, is for obviously time. Okay, similarly we had another system known as the MKS system, which was also known as the metric system, and in this we had small m representing meters. Okay, small m meaning meters, which represents once again the length. Similarly kilogram represents the mass, and second represents the time. Okay, so these were the originally designed unit systems that were in place in different countries. Okay, whereas it was found out that A little later it was found out and it was decided that instead of having so many different systems operational, why don't we have an international system which is applicable everywhere. Okay, so it was then that this MK system was further elaborated or converted into what was known as the SI system. Okay, and in this SI system we have the generic version which is applicable all over the world. So what do we have in the SI system? Now this SI system, if you have a look in this chart, I have detailed everything about the SI system. So we will come back to this a little later. First let us understand the meaning of the word SI. From where does this word SI come from? So it is, the full form is System International d'Units. Okay, so this is basically a French word. Okay, and this is now applicable all over the world. So we have in SI system, so once again, what should we have representing the length? We have meters representing the length, we have kg representing the mass, and we have seconds representing the time. Okay, so if now somebody asks you what is the SI unit of length, so you will say meters is the SI unit of length. Similarly, what is the SI unit of mass? Kg is the SI unit of mass, and seconds is the SI unit of time. Okay, so now the next question that comes to our mind is, can we use meters to find out the length of almost everything in the world? No. The answer would be no. Why? Because there are many things that are far smaller in terms of length when you compare them with meters. Okay, so suppose for example you see subatomic particles, or the distance between let's say for example two atoms and things like those, which cannot obviously be measured in terms of meter, which are far more smaller. Similarly, you will have distances or lengths that are far greater than what we can have meters to determine. So we can also have distance between the heavenly bodies. Okay, so if you have distance between the heavenly bodies, let's say for example any two stars, okay, the distance between any two stars, can it be represented with the help of meters? Obviously not. It is although possible to represent it in meters, but will it be appropriate? The answer is no. So we need to have some subunits, and we also need to have some multiple units, or the larger versions of the unit, the basic unit. Okay, so these are the basic SI units to represent length, mass and time. Please note once again that length, mass, time, these are the physical quantities that we are measuring, and mass, meters, kg and second, these are the units which are representing length, mass and time. Okay, so units are used, if you remember, for physical quantity. Yesterday we had discussed physical quantity is represented with the help of two things. One is the numerical value or the number, second is the appropriate unit. Okay, so these are the SI units. Now coming to the subunits in all the three categories, if you see, subunits are the smaller units. Okay, so you must have obviously seen millimeters, micrometers, nanometers. Okay, similarly the multiple units, or the larger version or the greater version of meter would be kilometer, which is a very commonly used unit. Okay, similarly when we go to mass, we have the SI unit as kg, but can we use kg to represent each and everything? Can we represent kg? Can we use kg to represent the mass of an atom? Obviously, it would not be appropriate. Can we use kg to represent the amount of the weight of the steel in an iron and steel industry? Obviously, this would not suffice. So we need to have subunits as well as the multiple units here also. So if you have a look, the smaller versions of kg, you have gram, then you have milligram, then you have microgram. Okay, similarly for multiple units, we have quintal, we have ton. If you go into the details in the book, if you read, you will find out the exact relationship also. 1 quintal is equal to 100 kgs, and similarly this ton, which is the metric ton, it's also known as metric ton. So 1 metric ton is equal to 1000 kgs. Okay, so you have this over here. Similarly when you go to time, second cannot represent each and every case with regards to time, so we need to have subunits of time also. So subunits of second, we will have millisecond, microsecond, nanosecond. Now these are just a few that I have mentioned. There are many more. You can go ahead and read in the book in detail. Similarly, multiple units. So what are the larger or the greater versions of second as the unit? So we can have minutes, we can have hour, we can have day, we can have week, we can have a lunar month, then we can have an year, then we can have a decade. Okay, so there are many multiple units when we talk in terms of time measurement. Minutes, hours, day, week, lunar month, year. And then obviously everyone knows 1 year is equal to in general 365 days. Then you have a decade, which is equal to a period of 10 years. Then we also have millennium, which is a period of 100 years. Okay, so these are some of the units, the subunits and the multiple units that we have discussed. Now coming to the left hand side of this table over here, these are some important prefixes that we need to study. The reason why we have to study prefixes is because of this table that we have discussed just now. You see, the SI unit of length was meter, as I mentioned, but sometimes obviously we have to use the subunits, which is like mentioned like mm. So what is that mm? Millimeters. Okay, so what is that prefix that we are using in meters? This is that meter and this is the milli part. Okay, so if you have a look over here, I have listed down some of the prefixes. Prefixes means things that you mention before the actual unit. Okay, so you have milli, micro, nano, pico. Okay, so these are some of the smaller or the smaller versions of the units that we have. Milli is equal to 10 to the power minus 3. Okay. So if somebody says what is 1 millimeter equal to, so you say 1 millimeter is equal to 10 to the power minus 3 meters. Okay, so that milli portion prefix means 10 to the power minus 3. Similarly, micro, you have 10 to the power minus 6, and this is the symbol for micro over here. If you see, this is the symbol for milli, as I have already told you, millimeters. Then you have micrometers. Okay, this is the symbol for micro over here. It looks like a U, but it's not a U. It has an extended arm over here. Okay, so micro is 10 to the power minus 6. Similarly, nano, you have 10 to the power minus 9. Pico, you have 10 to the power minus 12. Okay, so these are again some of the important ones that I have mentioned. Now moving on to the higher versions, you have kilo. Okay, so obviously you have kilograms. So kilograms, kilometers. Okay, so what does that kilo prefix mean? Kilo means 10 to the power minus 10 to the power plus 3. Similarly, mega is 10 to the power plus 6. Giga is 10 to the power plus 9. So if you have a look at the relationship over here, these are all in powers of minus and these are all having plus powers. Okay, so these are the greater or the larger versions and these are the smaller versions that we have. So in examples, we obviously have kilogram, megawatt, gigawatt and so on. Okay, so these are some of the important prefixes that we put in the SI units in order to create a more versatile picture of units. Okay. Okay, children, so the next thing that we have to discuss is the difference between the metric units and the non-metric units. Okay, so we'll take for example again those basic physical quantities, length or the distance, and then we have mass. These are the physical quantities. And till now what we have discussed is we have discussed kilometers, we have discussed meters, micrometers, millimeters. So if you see, all these have a meter attached to them. Okay, so they have been a version or they have been taken from basically from the word meter. Okay, so these are the metric units that we have. Similarly, in terms of mass, we have a metric ton. Okay, so these are the metric units that we have. Along with these, we also have the non-metric units, which are not taken their origin from meters. Okay, so non-metric units, if you talk in terms of the length or the distance, you must have heard a light year. Okay, so a light year is the distance traveled by the light in 1 year. So if somebody asks you what does this unit represent, which physical quantity does this particular unit represent, which unit? Light year. Okay, so light year, if you actually have that definition in the mind, you will recall that 1 light year is the distance traveled by light in 1 year. Okay, so ultimately what is it that is being measured? It's the distance that is traveled by light in 1 year. Okay, so this obviously is a unit which will represent the length or the distance. Okay, so once again, since it does not have meters attached to it, therefore this is the non-metric unit. Okay, and obviously in terms of the notation, you will write a small l and a small y, light year. Okay, and obviously it is used to represent large distances. Okay, so distances which cannot be or should not be represented in terms of meters or kilometers, far greater, far larger in terms of the value. Okay, similarly you have astronomical unit represented by a capital A dot capital U. Then we also have angstrom. This is one of the very important ones that is very often used. Angstrom, which is represented with a symbol of capital A with a small circle at the top, a hollow circle over here representing angstrom. Okay, similarly in terms of mass, you also have the non-metric units of mass which are like AMU and then the solar mass. Okay, so if you read the book, you will find the detailed conversions. Some of the conversions I have listed over here. Okay, 1 light year, the distance traveled by light in 1 year, when you try to convert it into kilometers, you get a value of 9.46 into 10 to the power 12. If you want to have a look at how this value came, you can use the basic concept of light year. Light year is the distance traveled by light in 1 year. So distance is equal to speed into time. So speed of what? Speed of light. And what is the time? 1 year. Okay, so you convert the speed of light into the SI units, and then you convert the time for which it is traveling, 1 year. So you convert that also into seconds. You will get the distance in meters. Similarly, you can convert that into meters also. Similarly, this angstrom, you will have 1 angstrom is equal to 10 to the power minus 10 meters. So it's a far smaller version in terms of the length. Okay, and this is a pretty large version or the bigger version or the greater distance or the greater length to measure. Okay, so I hope you are understanding the reason why we are discussing so many different units, because there are so many different and vast varieties of things that we have to measure, both in terms of length, mass, time, and so on and so forth. Okay, so similarly you have 1 atomic mass unit. These if you see the relationship, it is 1.66 into 10 to the power minus 27 kgs. 10 to the power minus 27 represents or tells us how very small this particular unit is. Okay, so it is like 0.00027 zeros and then a value in terms of kgs. Obviously, so what sort of a physical quantity will this unit represent? 1 AMU, atomic mass unit. So it is obviously going to represent mass, but mass of what? Mass of extremely light or light atomic level weights. Okay, so and obviously, as the name suggests, atomic mass unit. Okay, so when we go in terms of the levels of atoms and electrons and protons, and it is then that the weight of those things are to be represented. It is then that we use AMU. We can't, it won't be appropriate for us to use kilogram or quintal to represent such light particles. Okay, so similarly we have a solar mass, and if you see solar mass, 1 solar mass is equal to 2 into 10 to the power plus 30 kg. Okay, so this is like a very large value, a very big value. So obviously it is it will not be used to represent bodies that are light in nature. In fact, in contrast, this particular unit is a larger unit, okay, of mass. Once again, please remember, it is a non-metric unit. It does not have meters attached to it. So you have solar mass representing the mass or the mass of the heavenly bodies, okay, like stars, moons, planets, okay. So these this particular unit, solar mass, is used to represent extremely heavy masses, okay. So this was a basic idea of the metric units as well as the non-metric units and some of the other units. So now I'm going to end this lecture over here. I hope that you've got a fair idea of the units, the different kinds of units. Please remember the SI unit, System International D units. We have SI system as the most popular one in the world today, but obviously you must remember and keep a track of all the other units also, okay. So before we start with the new video, I would prefer that you go along with the revision of the previous two videos so that you are up to the mark before we begin with the next video, okay. Thank you.